Let's look at what is the binomial expansion now and how do we prove it. Alright. See, binomial expansion or binomial theorem, you can say that when you have a plus b whole power n, this can be written as nc naught a to the power of n plus nc1 a power n minus 1 into b plus so on and so forth till ncn b to the power of n. This basically is what we talk about, the expansion of the binomial theorem. Now we need to prove it mathematically. So to prove it, we use the principle of mathematical induction. Okay. So to prove it by mathematical induction, first what we'll do, we'll start by taking let P of n is equal to a plus b whole power n, which is nc naught a power n, nc1 a power n minus 1 into b, so on and so forth till ncn b to the power of n. This is p of n. Now we'll take p of 1. So p of 1 is a plus b whole power 1, which becomes 1 c naught into a to the power of 1 plus 1 c1 a to the power of 1 minus 1 into b. 1 c naught is 1, 1 into a power 1 is a plus 1 into a to the power of 0 is 1, 1 into b is b. So a plus b. Now it is proved. So what we can say, this implies p of 1 is true. Correct? Now we'll assume that let p of k be also true. Okay, p of k is also true. Now p of k is what? So p of k becomes k c naught into a to the power of k plus kc1 a power k minus 1 into b plus kc2 a power k minus 2 into b square, so on and so forth till kck b to the power of k. Isn't it? This is p of k. Now we'll take p of k plus 1. Now if you prove p of k plus 1 is true, then by induction p of n has to be true, correct? So p of k plus 1, this becomes k plus 1 c naught a to the power of k plus 1 plus k plus 1 c1 a to the power of k into b, so on and so forth till k plus 1 ck plus 1 into b power k plus 1. Correct? This is what we have. Now, what is p of a k plus 1? We can write this as a plus b whole to the power of k plus 1, isn't it? Now we'll use the normal multiplication of two binomials, algebraic method. We can write this as a plus b into a plus b whole power k, isn't it? We know what is a plus b whole power k, correct? Because a plus b whole power k is nothing but this p of k. We can substitute that here. So what we are going to get is a plus b into kc naught into a power k, kc1 a power k minus 1 into b, so on and so forth till kck b to the power of k. Correct? Now what we do, we individually multiply. Normal multiplication, how we used to do? Just individually multiply. In the sense, first we'll multiply a with all of them, then b with all of them. Alright. So now if you do this one, then you will get kc naught into a to the power of k plus 1, because a power k into a plus kc1 a power k into b plus the next one is going to be the same thing, dot 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 kck a into b power k. Correct? This is what we have. Now we'll have to do the same thing with b. Correct? For b, what we are going to get, so we will multiply b with this entire thing. Correct? So we are going to get plus. Next, when you multiply this one, I'll write it here. Plus kc naught into a power k into b, plus the next one is going to become kc1 into a to the power of k minus 1 into b square. Correct? So on and so forth. kck b to the power of k plus 1. Correct? So this is what we have. Now the first term, write it as it is. That you are not going to change. So we can write the first term as kc naught a to the power of k plus 1. Now what we'll do, we'll take these two. See, or just write it in different. See, take these two first. Now in these two, a to the power of k into v is common, right? Plus, what we can write, a power k into b, kc naught plus kc1, isn't it? Next, same thing if you do, then you can take a power k minus 1 into b square as common. Correct? So you will get kc1 plus kc2. So on and so forth till the last term, write it as it is. kck b to the power of k plus 1. Now, what is kc naught value? 1, right? Now, don't you think kc naught can also be written as k plus 1 c naught? Because both the values are going to be the same. In the sense, we can write the first term as k plus 1 c naught a to the power of k plus 1 plus. Guys, what is the value of this kc naught plus kc1? What is, okay, let's recap. What is NCR plus NCR minus 1? If you recap, it is n plus 1 CR. Do you remember? So let me write it down here so that it's going to be much easier for you. You have, see this here only, I'll just write it down. You have NCR plus NCR minus 1. This value is n plus 1 CR. So keep this in mind because we are going to use this here. Okay, so what do we have? NCR plus NCR minus 1 is n plus 1 CR. That means Kc naught plus Kc1. This particular value, this is going to become K plus 1 C1 into a to the power of K into B. So every time when you do this, you're going to get K plus 1 C2 a to the power of K minus 1 into B square. So on and so forth till K plus 1 ck plus 1 b to the power of k plus 1. You might be thinking, how did we get k plus 1 ck plus 1? What is NCN? 1. kck? 1. What is k plus 1 ck plus 1? That is also 1. All of them are 1 itself, isn't it? Now look at the result. What you have? K plus 1 c naught a to the power of k plus 1, k plus 1 c1 a power k into b. Don't you think this is the same as p of k plus 1? Isn't it? So what did we prove? From p of k, when we assume p of p of k plus 1, we proved that p of k plus 1 is true. Correct? So let's write it mathematically now. P of k plus 1 is true. Hence, p of k is true. This implies that p of n is true. Correct? Since p of n is true, that means what can we say? Therefore, a plus b whole power n can be written as nc naught into a power n, nc1 a power n minus 1 into b, so on and so forth till ncn b to the power of n. So this completes the proof of binomial theorem. So P of n, or a plus b whole power n, is going to give you this one. Now there are certain observations what you have to do for this particular derivation. Okay, so let's do simple math. Simple observation. Look at the power of a and look at the power of b. Now for the first one, for the first term, if you look at this, the power of a is power n. Next one is power n minus 1. Next e is going to become n minus 2. So on and so forth till the last term, which has a power of a as 0. A power 0 is 1, right? But look at the value for b. For b, the first one or the first term has no b. That means you can write b power 0. The next one, b power 1, b power 2, so on and so forth till b to the power of n. Correct? So the value of a is decreasing and the value of b is increasing. Now this is the general truth for all of them. That's why if you look at a plus b whole cube, a cube plus 3a square b plus 3ab square plus b cube. See the power of a from 3, 2, 1, 0. And look at the power of b, 0, 1, 2, 3. So this is the truth for all binomial expansion. So this is one of the observations, very important observation. That is the power of a, the first term always decreases. The second term power is going to increase. Now, in the same observation, it cannot just randomly increase or decrease, correct? There is a method or there is a pattern. Now, in all of them, I want you to see the powers. Add the powers. N minus 2, 2. This is 0, this is n. Add the powers, it's always n. Correct? Now, a decreases, b increases in such a way that the sum of their powers is always equal to n. In the sense, if you take a plus b whole cube, see this, a cube plus 3a square b plus 3ab square plus b cube. Now, if you take the sum of the powers, it's always equal to this particular power. If the power is 3, then it's 3. If the power is 5, it's 5. Whatever it might be. Understood? So, this is the second observation. The first observation is a decreases, b increases. Second observation is the sum of the powers is always equal to the total power what we have. Clear? This is the second observation what you can do. Now we'll go for the next observation. The third observation what we can do in this particular one, what if we have a negative sign in between? In the sense, what if you have a minus b whole power n? Then how are we going to undo this one? It's very simple. Put minus 1 alternatively, because think about it. Minus 1 whole cube is going to give us a negative sign. Again, we'll take it as an example and we'll do it. Now, let's start by taking n value as 3. That means we'll take a minus b whole cube. What is the expansion of this one? A cube minus 3a square b plus 3ab square minus b cube. This is the expansion, correct? So if you remember, you were writing a cube minus b cube minus 3ab into a minus b. Just expand it, you will get the same thing. Look at this. Alternate plus minus, correct? Now, if you have to write this in the binomial expansion form, we can write this as 3c naught a to the power of 3, correct? Plus minus 1 to the power of, we are going to write it as n. Okay, so n value is 1, 3c1 a to the power of 2 into b plus minus 1 whole square 3c2 a to the power of 1 into b square plus minus 1 whole cube 3c3 b to the power of 3. See, 3c naught is 1. So 1 into a cube is a cube. What is minus 1 power 1? Minus 1. So minus 3c1 is 3. 3a square b. Minus 1 square 1. 3c2 3. Plus 3ab square. Again minus b cube. See, this is what we have. That means a minus b whole power n can be written, a minus b whole power n can be written as nc naught a power n, correct, plus minus 1 nc1 a power n minus 1 into b, so on and so forth till minus 1 power n ncn b to the power of n. This is another general observation what we can do. Okay, now there are certain shortcuts we can say, small shortcuts. That also we'll just discuss about it. All right. Suppose if you have, say, 1 plus x whole power n. Okay, 1 plus x. This you can just write it as nc naught plus nc1 into x, nc2 into x square, so on and so forth till ncn into x power n. Because what is 1 power any number? Always 1. Now this particular term, the expansion, it's very helpful in solving problems. Very helpful. So this is one of the easier methods of doing this one. Understood? Same thing if you have 1 minus x, just put alternate plus minus plus minus plus minus. That's all. Very simple. Understood? So remember the observations what we have. One increases, one decreases. The coefficient, the sum of the powers is always equal to the total power. Okay. Now the most important part is the general term. Okay. Now the general term, always the general term is represented as the n plus 1th term in this case. Okay. So the r plus 1th term you can call it. So r plus 1th term can be written as ncr a power n minus r b to the power of r. Because think about it, the first term is nc naught, nc0. Second term is nc1, 1. So r plus 1th term becomes ncr a power n minus r into b power r. Clear? So this is what we have, and the binomial expansion can be written as a plus b whole power n is sigma r is equal to 0 to n ncr a power n minus r into b power r. Remember, this is very important. Very important. And the next one, what is important is this one, the general term. Clear? So with these two, in the next video, we'll solve problems on this. Now, there are 3 or 4 types of problems in this. Okay, so the first one is going to be just normal expansion. Okay, and other types we are going to discuss about these things in the next video.